Hello students, I am Ritika Gaur and we are back with the last segment of Geography Chapter 5 Minerals and Energy Resources. So let's start. Energy generated by using wind, solar, small hydro, tides, geothermal heat and biomass is known a non-conventional energy. All these sources are renewable process of energy generation and do not cause environmental pollution. They are also known as renewable sources of energy. Nuclear energy or atomic energy. Now, how is energy derived from nuclear sources? Nuclear energy means from the nucleus we have an atom. When the atom releases, it releases certain amount of heat energy. Using this heat energy or the atomic energy, we can generate electric power. This breaking of the atoms would result in the release of exhaustive heat that is used to generate electricity. This kind of breaking of atoms can be happen between the elements like uranium and thorium. These two elements are abundantly available in Jharkhand, specifically in our country. Now, let's study about solar energy. India is basically located in 8 degree north to 37 degree north of equator in northern hemisphere. India comes in the category of tropical countries, so it is clearly evident India receives a huge and bulk amount of sun rays. This solar energy from sun rays is the clean and environment friendly energy source, and nowadays it is becoming the most viable possible alternative for all the countries in the world, especially who can have the possibility of getting sun rays in huge amount. This has been a great standard example where the largest solar power plant has been established in Bhuj, where it is being used to sterilize milk cans to make them always be hot. There are many ways to use energy from the sun. The two main ways to use energy from the sun are photovoltaics and solar thermal capture. Photovoltaics are much more common for smaller scale electricity projects like residential solar panel installations, and solar thermal capture is typically used only for electricity production on massive scales, as the example we have given in the earlier about Bhuj, like in utility solar installations. In addition to producing electricity, lower temperature variations of solar thermal projects can be used for heating and cooling. Next possible alternate is wind energy. India is having a huge wind power, and so India is also called a wind superpower country. In our country, the largest wind farm cluster is located in Tamil Nadu from Nagarkoli to Madurai. Jaisalmer is also known for effective use of wind energy. Wind power or wind energy is the use of wind to provide the mechanical power through wind turbines to turn electric generators and traditionally to do the work like milling or pumping. Wind power is a sustainable and renewable energy and has a much smaller impact on the environment compared to burning fossil fuels. The wind is an intermittent energy source which cannot make electricity nor be dispatched on demand. It also gives variable power which is consistent from year to year but varies greatly over shorter time scale. As the proportion of wind power in a region increases, more conventional power sources are needed to back it up, and the grid may need to be upgraded. Biogas is a type of biofuel that is naturally produced from the decomposition of organic waste. When organic matter such as food, scraps, and animal waste break down in an anaerobic environment, that means an environment absent in which oxygen is absent, they release a blend of gases, primarily methane and carbon dioxide. Because This decomposition happens in an anaerobic environment. This process of producing biogas is also known as anaerobic digestion. Due to the high content of methane in biogas, typically 50 to 75%, biogas is flammable and therefore produces a deep blue flame and can be used as an energy source. Tidal power or tidal energy is the form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. Although not yet widely used, tidal energy has the potential for future electricity generation. Tides are more predictable than the wind and sun. Among sources of renewable energy, tidal energy has traditionally suffered from relatively high cost and limited availability of sites with sufficiently high tidal ranges or flow velocities, thus constricting its total availability. However, many recent technological developments and improvements indicate that the total availability of tidal power may be much higher than previously assumed. Tidal power is the only technology that draws an energy inherent in orbital characteristics of Earth Moon system. A tidal generator converts the energy of tidal flows into electricity. Greater tidal variation and higher tidal current velocities can dramatically increase the potential of a site for tidal electricity generation. According to the estimates of the Indian government, the country has a potential of 8,000 megawatt of tidal energy. This includes around 7,000 megawatt in the Gulf of Cambay in Gujarat, 1,200 megawatt in the Gulf of Kutch, and 100 megawatt in the Gangetic Delta in the Sundarban regions of West Bengal. Geothermal energy is the thermal energy generated by the radioactive decay of materials in the Earth's interior, and it can be harnessed virtually anywhere on the Earth, but viable methods are possible only at the surface or near surface manifestations. These manifestations are only limited to some parts of the world. It is a very nascent renewable source of energy. Even though surface manifestations like hot springs have been used by humans since ancient times, the first geothermal pump were used in the 1940s. Several factors need to work together to make an area to be feasible for harnessing geothermal energy. There needs to be a geological heat source relatively close to the surface at an approachable depth. There are two basic types of geothermal heat resources that can be harnessed. The first type is a hydrothermal heat source. In this scenario, the heat is transferred by water to the surface. Water is recharged into the ground by rain or surface bodies like rivers, lakes, or glaciers, and is then heated by underlying hot rock, which is hot due to seismic or volcanic activity. The presence of hot springs in the Himalayas is an example of this. The second type of resource extraction can be done by deep enhanced geothermal systems in which a deep borehole is dug to reach the hot basalt rock and then water is pumped into the holes to obtain steam, which is aimed to run turbine. Assessing the deep basalt rock bed is an expensive process and hence this method isn't as popular. Energy conservation is the effort made to reduce the consumption of energy by using less of an energy service. This can be achieved either by using energy more efficiently, that means using less energy for a constant service, or by reducing the amount of service used, for example, by driving less. Energy conservation is a part of the concept of eco sufficiency. Energy conservation reduces the need for energy services and can result in increased environmental quality, national security, personal financial security, and higher savings. It is at the top of sustainable energy hierarchy. It also lowers energy costs by preventing future resource depletion. Energy can be conserved by reducing wastage and losses, improving efficiency through technological upgrades, and improved operation and maintenance. On a global level, energy can also be reduced by stabilization of population growth. Now students, at the end, do the questions given in this checkpoint and also practice the map work related to chapter and paste the complete map work in copy. Thank you.